Okay, so let us start. So first of all, just tell me, how do you differentiate the simple chain with the kinematic chain?
Sir,
What is the difference?
kinematic chain uh, is the chain of rigid link which can have relative motion, which is used in different mechanisms. But a simple chain is used to transfer rotational motion from one part to another point. It is used in tension.
Yes, repeat this one. What is the definition of simple chain?
It is used to transfer rotational motion from one part to another. Rotation of shaft from one
Okay,
point to another point.
so in simple chain, we only transfer the rotation.
Uh, Sir, it is mainly used in tension.
Tension.
Yes,
How?
uh, sir, it can be used to uh, uplift weight or convert rotational motion to one part to another.
Mhm.
The main thing is in tension. The chain will be in tension.
Okay, okay, okay. How do we calculate the degree of freedom of a mechanism?
Sir, for planar mechanism, equation is 3 into L minus 1
Mm,
minus 2j minus h minus fr. F where L is the number of links, j is the
mm.
number of lower pairs, h is the number of higher pairs, and fr is the redundant motion.
Okay, and what does the physical degree of freedom signifies for a mechanism and for a simple link?
Degree of freedom is the number of independent inputs need to be defined to specify the state of the system, such as configuration, velocity, different
Mm,
output.
mm. Okay, and what about for for the links? What does it
Uh,
signifies?
uh, so for link in a plane, if there is no constraint about the relative motion, it can have 3 degrees of freedom. You can
No, that
translate.
is okay. That is okay. But what does it signifies?
It can have three independent motion.
Mm.
It can independently move in mutually perpendicular directions. Also, it can rotate in that plane also.
Okay. Let us suppose if you have two links and you are just making a turning pair. Okay,
Okay.
between the two links, then how many motions are going to be restricted?
If it is not attached to it is if on sir, is that one link is attached to the plane or reference plane?
No, no, I'm just saying there are two links. Okay, and they are
Okay.
connected by a turning pair.
Okay. Okay.
How many motions are going to be restricted here?
Two motions, sir.
Two motion. Are you sure?
Two independent motion, two relative motions are
Mm.
restricted. It can only rotate about one another.
Okay, then what will
As
be
a
the value of the
combined
degree?
form, it can move in space. As a
No, that tell me what will be the degree of freedom of that particular mechanism of that joint.
1 degree, sir.
1 degree.
Yes, sir.
Okay. Okay. What is Grashof law?
Grashof's law is used for four-bar mechanism to predict where a continuous motion of a link can be obtained or not. For a four-bar mechanism, the shortest link, sum of the shortest link and the largest link should be
Mm.
less than the sum of the
Mm.
other two links.
Okay. And what is binary link? Sorry, quaternary link and quaternary joint.
Uh, in quaternary joint, there are four uh, links are attached. Uh,
Mm.
quaternary joint, and sorry, sir, can you repeat it?
I just want to know what is the quaternary link and what is quaternary joint.
Sir, is quaternary, sir, quaternary link, it is attached with the four, sorry, quaternary, yeah, it is attached with the two, four other links which can have independent, sorry, relative motion. Ordinary John. Sorry, sir, I don't
Mhm.
exactly remember everything.
Okay. Okay, that is okay. Okay. Okay, what is positive drive and negative drive?
Positive drive and negative. Sir, if the two physical surfaces are in contact and that passes the drive, then it is positive drive. And in case of frictional force is used, then it is a negative drive.
Okay. What is toggle position in a mechanism?
Toggle position. In toggle
Mhm.
position, the output link velocity becomes zero.
Okay. So what will be the toggle position in the case of double rocker mechanism? Double crank mechanism, sorry.
So, sir,
What will be the toggle position in case of double crank mechanism?
double crank.
Mm.
Sir, it is the in that position input link and the connecting rod. Sorry, coupler will have 180 degree in between them.
No, I'm just saying what will be the where will be the toggle position in the double crank mechanism?
Uh, in double crank mechanism, the crank and the coupler will
Mm.
align in a line. It will be
Mm.
collinear. Uh, then, uh,
Okay.
then the output link velocity becomes zero.
Okay. And what is transmission angle?
It is the angle between coupler and output link.
Coupler and the output link. Okay. Okay. Just tell you one thing. What is sorry, what is conjugate profiles in gears?
So conjugate profile are profiles which will give a constant velocity
Mm.
ratio. Uh, in that, the common normal will pass through the pitch point of the two
Mm.
gears.
Okay. Okay. And how many types of conjugate profiles are there?
So there may be infinite many conjugate profiles can be we can make uh, specifically construct, but commercially we use involute and
Mm.
cycloidal profile.
Okay. And what is the difference between these two profiles, the involute and the cycloidal profile?
Uh, in um,
Mm.
in involute profile, pressure angle remains constant. In cycloidal profile, pressure angle changes. And in involute profile, it is a single curve gear,
Mm.
and in cycloidal, it is a double curve. It has an epicycloidal path and as well as a hypocycloidal path. Uh,
Mm.
involute profiles are cheaper to manufacture, and
Okay. How does the pressure angle varies in this profile?
in cycloidal,
In both.
involute profile has a constant pressure
Mm.
angle, and cycloidal profile it is maximum when first engagement, and it becomes
Mm.
zero at the pitch point, and again goes to maximum at the
Mm.
point of disengagement.
Okay. And what is interference?
So interference is when uh, non-involute parts of the part of the gears are getting contact. Interference occurs.
Okay. What is the why do we make the pressure angle as 14.5 degree or 20 degree? Why it is always
Sir,
taken between these two values?
increasing pressure angle will increase the radial force. For transmission of power, we need more tangential force.
Mm.
Increasing more than 20 degree will sufficiently largely increase the radial force, separating force between
Okay. And how do we define the pressure angle in CAM?
pressure angle in cam.
Mm.
Uh, it is the angle. It is the angle made between the normal to the cam and
Mm.
axis of the
Mm.
follower.
Okay. Where do you find the application of CAM?
So it is used in IC engines for actuating the valve.
Mm. Okay. What is the speed of the camshaft as compared to the crankshaft?
It is half.
Why?
Sir, for a four-stroke engine, it need to be. Sorry, sir, I don't exactly know.
Okay. Okay, what is the difference between the flywheel and corner, and which is essential for an engine?
Both are essential for engine. Governors are used to control fuel supply
Mm.
according with the external load. Governors are used to control the speed in inter cycle. When in flywheel, it is used to control the speed variation in intra cycle.
Okay. Okay. Okay, that is okay. Uh, okay, just tell me one thing. Do you know anything about the vibrations?
Yes, sir.
Okay, what is the difference between the overdamp system and the underdamp system?
Sir, overdamped system is aperiodic. It doesn't oscillate.
Mm.
Underdamped system oscillate and uh,
Mm.
it has a logarithmic decrement of amplitude. It will eventually
Mm.
uh, comes to rest after some time, after oscillating some time. It is periodic
Okay.
motion. That overdamp is unperiodic.
Why can't we consider the overdamp system as a vibration?
Sir, when if it is disturbed from its mean position, it will comes to mean position after some time without any vibration. It is exponentially decrease its displacement and comes to a mean
Mm.
position. While the underdamped system, it will go through a vibration motion, to and fro motion. After sometimes it will comes to rest
Okay. Okay. Let
into
us
mean
suppose if there's
position.
a let us suppose if there is a simple engine. Okay, on which the force the excited frequency is, let us say, twice of the natural frequency.
Sorry, sir.
Okay,
Sorry.
let us suppose if the excited frequency on the system is twice the natural frequency. In that
Uh,
case, do you require any type of damper in the system?
exciting frequency is double the.
Double the natural frequency of the system. In that case, do you require any kind of damper here to control the transfer of forces from the system to the foundation?
Okay, sir. So can I write the case?
How much damping will you require there?
Okay. Sir, for omega by omega, and if it is 2, then there will no need for damper.
Why so?
Sir, if omega by omega n is value is root 2, more than root 2, then the
Hmm.
lowest transmissibility is occurring at a uh, eta equal to 0. Factor coefficient is 0. Damping coefficient is 0.
Okay. Okay, Sabri, let me provide my feedback. See, first of all, just revise the theorem machine one more time. Okay, because you need a revision on the simple mechanism part. That is very, very important. Okay, and also
Okay.
do study the some portion of the motion analysis of mechanism.
Motion
Okay, that
analysis.
is also yes, motion analysis or velocity analysis of the mechanism. Okay,
Okay.
that is also very important. And after that, the remaining questions which is the remaining answer which are given me regarding the gears and vibrations are correct, but the answer related to the cam is not up to the mark. Okay, so you need to work on that particular thing also.
Okay.
Okay, and also on the delivery part, uh, I always feel that you are getting nervous or you are having some difficulty just picking the words here. Okay, so just go through the revision of all the favorite subject which you are considering for the interview. Okay, and don't make me feel that you are feeling like nervous here. Okay, you have to be very confident with your answer because the answer which you are providing me regarding the gears and vibrations are correct. There is no need to worry. Okay, everything is good here. but you are taking too much time for picking up the correct words. Okay, so just work on these things.
Okay, sir.
Okay, anything,
Sir,
anything you want to
sir,
ask? Hmm?
sir, there are plenty of topics in theory of machines. So, what to focus on? There are governors,
See,
dynamo.
first of all, you have to, you should know the basics of each and every topic. Okay, just
Okay,
basic. Like when I've told you that what is the required component within the flywheel and governor, you should know that the flywheel is used for controlling the cyclic variation.
okay,
Okay, so flywheel is a very essential component as compared to the governor. So if you are not using the governor in the system, that is okay. Okay, because you can control the fluctuation by just controlling the load here. Okay, on its own, you if you are not maintaining the load variation, then you need a governor. But if you see, in any engine, the cyclic variation is always going to be there. Whether it is a two-stroke engine or whether it is a four-stroke engine, in that case, you have to make sure that flywheel is operating in the system. Okay, so just go through all the basic things of all the chapters of theory of machinery. Okay, you don't have to cover the entire topic in depth. Okay, in the theory of machine, just go have an overview of each and every topic. Like in
okay,
the case, of CAM, the terminology is very important.
okay,
Okay, terminology with the gears also the terminology is very important. The interface problem is what is interference, and in the vibration, if I say what is overdrive system, critical time system, and the underdrive system. What is critical speed, welding speed, whipping speed? Okay, the transmissive, the graph between the transmissibility ratio with the frequency ratio. You should know that. Okay,
mm,
so and same like that in the balancing part, you should know that how do we do balancing of the systems. You don't have to study the dynamic analysis of the single side effective mechanism. You should know the basics of the uh, balancing portion. That why the balancing is required. Okay, from where the unbalancing forces are producing there. You should know that.
okay, okay,
Okay, so don't think that you have to just use a specific. You have to do. You have to cover the a particular topic. Just go through the overall. Just get the basic idea of each and every topic from the theory of machine. Okay, you don't have to require. You don't have to prepare in depth of that particular topic. Okay,
okay.
anything else?
Nothing, sir. Sir, what is the
Okay.
difference between kinematic chain and chain?
See, simple chain means when the number of links are connected in such a way that the first and the last links are connected to each other. That means it is a simple chain. Okay. But
Oh,
when the output motion which I'm getting from the chain is constrained one, then it is the kinematic chain. In this kinematic chain, the degree of freedom is going to be equal to one. What is that degree of freedom one here? That is, you are required one input to get the desired one output.
okay, sir,
Okay,
that
so
mechanism.
basically in the case of a kinematic chain, the degree of freedom is going to be equal to one, and there we get the constrained motion from the output link. Okay, but in
Okay,
this simple mechanics, it is not necessary. Okay, the simple chain can be a superstructure, it can be a constrained chain, or it can be an unconstrained chain also.
okay, sir.
Okay, so in simple chain, what is happening? All the links are connected with each other in such a way that the first and last link are connected. Okay, now.
Okay, okay, okay,
Okay, Sabri. So now let's we can leave the meeting.
okay.
Okay.